So how do we make an extendable wire? Well, let's just look at the head cells of the wire. So this is the program channel, this is the control channel, and this is the target cell. And a lot of times we'll just indicate the target cell with an asterisk. It says that's the cell that's being configured by this wire. Now we have multiple PC and CC cells off to the left here, but for clarity I'm just showing the head of these cells. So this is the head of the wire. And here's what we're going to do. So here's the D input, here's the C input. We are going to build the following circuit. We're going to take data from the west and send it to the east. And this will generally be bidirectional, but I'm going to try to keep these drawings as simple as possible. And we're going to take data from the south, and we'd like to use that to control the C input. So everything else will be a data input except for this one over here. So we'll just assume all these inputs and outputs are D. Okay. What we want to do is we want to take signals that are coming along this control channel, and in some cases we want to send them up here if we're at the head of the wire. If we're not at the head of the wire, we just want to send them straight through. So how can we do that? Well, instead of reconfiguring the head cells to change the configuration of this, we're going to use a single cell and we're going to signal it as to whether it's at the head or not. And we're going to do that by using a feedback signal. So every cell that we build along the program channel will send a 1 out to the south, and every cell along the control channel will take whatever's coming in from the north and send that out to the west. Simultaneously, we will take the data coming in from the east, and we will use that in two ways. So we're going to do an AND operation, and it's going to look like this. So these are both AND gates. So if we have a 0 coming in from the east, that'll get inverted to a 1, and that 1 will get ANDed with the control signal channel, and that will come out to the north, which will go into the C input of the target cell. So in our normal case, where this cell over here has not been configured, it's just got a bunch of zeros in its truth tables, this control channel input will get sent to the north and will give us control over the C input of this target cell. But once we configure this cell to be a new head cell, it's going to be putting a 1 out to the south, and this cell is going to be copying that 1 over to its west, and so we're going to be getting a 1 coming into here. And in that case, that 1 gets inverted to a 0, and that gets ANDed with our CC, so the CC will be blocked from going up here, and we'll no longer be configuring this old head cell. On the other hand, since we have a 1 coming in here, that will get ANDed with the CC signal coming in and will come out here. So the effect is, if you're at the head of the wire, the control signal simply comes up to the north, gives you control over this target cell C input. If you're not at the head of the wire, the control signal simply gets passed from west to east. So you have this big long line of cells transferring the control channel data from west to east until it gets to the head, and then at the head it turns north, and the head cell on the PC channel takes that signal and uses it to control the cell to the right. So to extend this wire is very simple. We simply need to configure these two cells to look like these two cells. And we can do that in 3 simple steps. In the first step, we configure this cell to take data from the west and send it out to the south, and to send a 1 into the control input on the south. In the second step, we send in the truth table bits corresponding to the new control channel cell. So we take the truth table for this circuit, we send that into the D line, that will get loaded into this cell's truth table, and this will become a new CC cell. And then in our third step, we simply configure this to be a new PC cell. As soon as we start configuring this, the C input will be 1. That will force this C output to drop to 0, because the cell that's being configured is not allowed to configure any other cells. So as soon as we do that, this will drop to a 0, and we'll no longer be configuring this cell. So this will be set up as the CC channel head. And now we send in our new configuration that corresponds to a PC head cell, which will be data goes over here, data from the south goes here, and the 1 goes down to the data input. And this has already been set up with all of this circuitry. And so after we configure this cell and we put this piece of the circuit in here that puts a 1 out to the south, when we stop configuring this cell, we return it to C mode. This 1 comes down and it feeds back into this old head cell on the CC line, and that switches the head cell so that the control channel no longer goes up here but instead comes across here. Simultaneously, assuming that this region over here was initially blank, we have a 0 coming in here that gets inverted to a 1 ANDed with a control signal. So now any control signal that we send along the CC channel will come out to the north of this new head cell and will give us control over the C input of this new target cell. So we've extended the wire, and it's not as ugly as it seems once you understand and believe the basic process and how it works. It's very sort of automatic to go ahead and start using this in a way that lets us build all kinds of complex dynamic structures. So this is the notion of wire building, which we'll talk about in the next lecture.